Okay, so we are going to be talking about volume of prisms and cylinders. We'll first need to understand what the heck volume is. And in order to do that, we are going to go back to our 2D object. So bear with me for a minute. So if we have a two-dimensional object and we are talking about if I have this is, let's say, 4 feet, and this is 2 feet. When we are trying to find the area inside of it, we multiplied, in this particular situation, this length times width. So we did 2 times 4, which gave us 8, and it is feet squared. The reason why it's squared is because each one of these would be a square unit. Moving on to 3D, if you have a much bigger item, and we're working about 3D, I'm going to kind of just leave it hanging there for a minute. Let's say that this is units. Well, we have more space to fill, so we're looking at cubed units. So we're looking at how many cubed units would have to be stacked in order to fill this space. So it's not just individual squares. I think of squared tiles. I'm thinking if I have a square container and these are like sugar cubes, how many sugar cubes would it take? So if we're talking about 3D, we're looking at whatever units are now going to be cubed because they are in 3-dimensional. So when we are looking at the volume of a prism, and remember by definition of prism, you have 2 bases that are the same. We're going to draw our rectangular one. Actually, I'm going to do a quick off to the side. I'm going to show you a quick way of how to draw a prism. So if you have a rectangle, and again, this is usually easier because I'm doing it on pencil, but I don't think you'll see that on my video. Whatever shape you have, draw another shape exactly the same size of that, and then connect all of your vertices. So on the dry erase board, I would be cheating a little bit and erasing those pieces so I clearly get my dotted line, which are my edges. Okay, so just a quick tutorial on how to do those. So on the volume, if I have that this is 4 feet, 8 feet, and by 7 feet. The volume for a prism formula is the area of the base times the height. Now, we've dealt with base times height before. Let's go back up to this one real quick. This was that the area equals base times height. Notice it's a lowercase b. That is for base. This is a capital B. Capital B is representing the area of the base. So think of this almost like a formula within a formula. So depending on what your base is, that's going to change your capital B. So in this one we have a rectangular prism. So in a rectangle, I'm looking at the base. In a rectangle, my base, or the area of my base, is base times height. And then this is the height of the prism. So just because I have an H here and another H here does not mean that these are the same things. Okay? So remember, this is representing the area of my base. So the area of my base is right here, which is 4 times 8, times the height of my prism, which is going to be 7. So I have the volume equals 32 times 7. So the volume equals 224. We are dealing with feet. So this is going to be feet cubed. Okay. Let's do another figure of a triangular prism. We're going to label this as example 2. I should have labeled the other one as example 1. So in example 2, we have a rectangular prism, or excuse me, a triangular prism. So again, these should be dotted. Okay, and I'm going to put a right triangle or right angle indicator in there and make that a 1 and a 1 and an 8. So the formula does not change. It is the area of my base times my height. Well, what shape is my base this time? Shape of the base is a triangle because it's a triangular prism. So the area of my triangle, or the formula for the area of my triangle, is 1/2 base times height. Bringing down the height of the prism. So I have V equals 1/2. The base of my triangle is 1 times the height of my triangle is 1. The height of my prism. Now this one kind of gets people. Think of this if you were to take it and set it on its base. How tall is this going to be? It's going to be whatever 8 units is representing. So 1/2 times 1 gives me 1/2 times my 8. So my volume is going to be 4. I don't have any units marked, so I'm just going to mark it as units cubed. Okay. The reason why prisms and cylinders are in the same section is because they have the same formula. So if we have a cylinder, we're going to name this as example 3, and I have a paint can, for example. If this is 8 inches tall, and my radius, we're going to label it as, a different color here, 3 inches. The formula does not change. It is still the volume equals the area of the base times my height. But this time, the area of my base, or my base shape, is actually a circle. So when I am thinking of this, my base is a circle, and I know that the area of a circle is pi r squared. And then the h again is going to be the height of my prism. So what I like to tell my students is that, yeah, it's another formula, but if you remember the first one of the volume equals the area of the base times the height, you're going to remember this one. Okay? So volume equals pi does not change, radius squared times the height of the can. And with volume equals 72 pi, and I'm going to grab my calculator, and I get the volume to be 226.19 inches cubed. So you can look at the volume of a cylinder is pi r squared h. And you can also just remember area of the base times the height. Either one of those will work. You will be working also with some complex or composite figures, such as if you have, do the same cylinder, for example. We're not actually going to do this one. But if I were to have this, let's say this is a block of wood. If I were to drill a hole into this block of wood, oopsie, that should be dotted. Okay, that just changed, so now the volume is just what is on the outside because it now has a hole in it. So we're going to be working with composite figures like that as well.